Hey everyone, welcome to another episode of my Web Fundamentals series. In this episode I want to cover HTTP status codes. This topic is important as it tells you how the server is processing your request, what it may mean, and how we can use that information to leverage for a further attack or further understanding of the application. In this video you will learn about the common HTTP status codes, what each of them are, what they mean, and what we can do to leverage the information to further our attack on a system. I will give examples where I've come across certain status codes in certain conditions, so you guys can have an understanding of why we may receive them, what we can do with that information, so we can see what's going on under the hood. The codes go from 100 to 500, so 100 is informational, 200 is success, 300 is a redirection, 400 is a client error, and finally 500 is a server error. An informational will talk about basically has the server received something, a 200 will say if it was successful or not, a 300 will cover a redirection, for example, redirecting you to a new page. 400 is a client error. This will be the case of, say, you send an invalid HTTP request. And then finally, 500 is if the server has broken in some description. For example, you sent a malformed bit of data, such as some serialized data, and that has broke the Java deserializer. For example, let's kick off with the 100 informational status code. You won't ever really come across this, but in the event you do, it's worth knowing. Really, it's a case of the server saying, hey, yes, I received your request, just carry on, and that's pretty much it. There may be cases where a developer has implemented this in a bespoke fashion. I can't think of any examples where I've come across this and it's actually been useful, but really just think of it as a way of the server saying, hey, I've received your request, carry on with whatever you're doing. That's really what you need to think about. Next, we'll take a look at the 200 success status code. The 200 series of status codes generally means that the request was successful and the browser has received the expected information. This is generally what you want to see, as it means the request was successful and is being received, understood, and accepted by the server. It's also important to note, though, that sometimes 200s can be generic. For example, you may send a request to a non-existent resource and the web server responds with 200 anyway, so it can be a little bit misleading. So it's very important to actually validate if you're getting wildcard responses versus just 200s on an actual existing resource or URI. The 201 can often be received when you are creating a piece of data. For example, we're using a put request to create a piece of data. I've done a video on that previously, so go ahead and check that out if you haven't seen it already. But basically the 201 can be used to say, yes, some data has been created. This is really down to the developer to implement this functionality. Often it will be a case of configuring it to do so. There may be cases where it doesn't do this and it just gives you a flat 200, but often if you get a 200 or a 200 series, it basically means your request was successful. You may get a 202 response. This kind of just means the server has taken in your request, but hasn't performed the action it should relate to, and it basically can't promise you that it's going to get done, but it's accepted it anyway, and whether it gets done or not is really down to the server. It's a little bit ominous in that way. There are more 200 series status codes, however these are the main ones that you will come across on the day-to-day. And really to summarize them, if you're getting a 200 it often means that, for example, your authentication or authorization is okay, the data you're sending is okay, you've created a bit of data and that's okay. It doesn't necessarily mean that the data you sent has been acted upon. For example, you could send, say, a post request and that post request data might not be processed, but it could at the same time have just been received but nothing has actually happened. So it's really down to you to understand what's going on under the hood, as to say, okay, I sent a post request, is it actually going to be processed? Am I using the right name value pairs, etc.? And that kind of thing. It's really a case of knowing how the page should respond should you send a piece of data. For example, you may send a post request with some name value pairs and you actually get a 201, whereas when you send it without the name value pairs, you get a 200. So really it's a case of just reading the status code and saying, okay, what can I imply from the response I'm getting from the application or web app? Next, we'll take a look at the 300 series of status codes, which means a redirection has taken place or due to take place. The 300 series of status codes refers to a redirection of some kind. Often you're going to get a 301 or a 302. An example where you may get one of these is where you say go to admin.php and you're not currently logged in. So what it will do is it will then redirect you using a 301 or 302 status code to, say, login.php, and it will do this by providing the URI in the location header in the response, which your browser will look for and then redirect you to login.php. Often when you receive a 300 series response, there won't be a response body. It will often just be the headers and the appropriate status code. Due to this nature, it's very easy to just ignore the request and move on to wherever it redirects you to. But it's important to think about the way that it's put together, in the sense of the 300 may redirect you, but a response body may still be provided. Let's say we go to admin.php and we are redirected to login.php. Well, admin.php may have, say, some sensitive information on there, perhaps passwords or whatever, and it may actually provide those in the response body to us, but our browser just follows simply the 300 response and then redirects us to login, and therefore we miss that data. That's why it's important to look at, say, the response length to say, oh, actually, rather than just getting, say, a couple hundred bytes in headers, we actually got a few thousand bytes in response because we actually received a response body versus just the standard 300 series status code and the relevant headers. There are a few CTF style challenges where this is the technique used. I'll go ahead and link them in my description. Another status code you may come across is a 304 not modified. This is used for caching purposes. Often when a server wants to reduce latency, what it will do is it will use caching. Let's say we go to an image, caching headers will be set, say, when we last looked at this image. When we make a request to a web server for that image, the web server will then check our caching information if our cached image is different to their version. If it isn't different and therefore the same, what it will do is it will then issue the 304 not modified header to say, hey, your image you already have in your cache hasn't changed since. So we're not going to provide you the response body, and therefore don't do anything really. Just here's our headers, take a look in your own cache for it to save latency. Next, let's take a look at the 400 series status codes. The 400 series of status codes relate to a client error response, basically something that the client messed up on. For example, we submit some malformed HTTP request or data. Perhaps we aren't accessing the resource using a properly formatted cookie, or really we just made an error, the client has made an error. The 400 response status codes effectively just tell us, the client, that we messed something up, that it isn't the server's fault, that we need to adjust our request to make a successful request to that endpoint. The 401 status code is effectively telling our client that we are not authorized to access a certain resource or URI. In this case, it's saying, hey, you need to authenticate to be authorized to access this resource. It doesn't tell us what we need to do to authenticate or how to authorize, but it merely tells us that we can't access that particular resource given our current authorization access. This could perhaps be fixed by fixing a cookie we have that's used to authenticate to that session, or anything like that. It's really down to you, the client, to review the web application. Say, okay, how would it want me to authenticate? How can I authenticate? Perhaps it's something simple as just forcing some authorization headers in your request, and maybe then it will work. Of course, you need to know the username and password combination, but, from a brute force perspective, that's not so difficult to do. Really, it's a case of just, saying, okay, if I'm not authorized for a certain resource, how can I get around that authorization? How can I get access to the page? How can I, what do I need? Do I need to further my attack? Do I need to get creds? Is there an alternate way? Is maybe a way that I can get that information without actually being authorized? Perhaps using, say, like a server-side request forgery attack where you actually make the server request that data rather than yourself. Next, we have the 403 forbidden. This is very similar to the 401 unauthorized, except in this case the server has knowledge of who you are, in the sense of you may be logged in or something like that. So the server knows who you are and is saying, we know who you are, but your current access level dictates that you can't access this resource. It's saying that we know you, but you don't have access, so you might have a guest account, but really you need an admin account to access, a certain resource or URI, that kind of thing. Then we have the 404, not found, which I'm sure you've come across a million times. Simply, this is the server saying that the resource that you're trying to access doesn't exist. There may be cases where it indeed does exist, but the server has given you a 404 anyway, just to kind of like lure you away from it. There could be cases where, for example, you're trying to access a forbidden URI, but it's just giving you a 404 to mask it. So really, the resource does exist, but it's giving you a 404 because you're not authorized to access that particular resource. I found that in many cases. It's a pretty sneaky way, but it makes a lot of sense, because if you tell a user they can't access a certain resource because they've not authorized, they might want to poke around at it more, whereas if they just tell the user it's a 404 and doesn't exist, they're probably going to move on to something that does exist and, lure you away from the crown jewels kind of thing. Then we have the 405 method not allowed. This is very similar to, in the sense of when we're sending the options HTTP header saying, hey server, what methods do you accept? Well, in this case, if we went and sent, say, a post request to a URI that only accepted GET requests, the web server may then reply with a 405 method not allowed, simply telling us that, hey, you sent a post request, but you can't really do that, we only accept GET requests or something similar to that. There will be cases where the server is doing this in a more deflective way, so it's saying you can't use post, but really the code might actually accept a post request. Maybe the code is actually configured to accept post requests, but this web server is kind of configured not to allow post requests, but the request may still go through to the underlying code. So again, a lot of these status codes, they're merely to help you, but it doesn't mean that what they say goes. There could be cases where it says method not allowed, post, but in reality, your post request is actually being processed by the backend code. So as I've said before, it's really imperative that you understand what's going on under the hood and basically look for anomalous activity. If you send a post request and something different happens to a GET request and it's not just a status code, then maybe you have something that someone else has missed because they just assumed that the 405 was saying, no, you can't do this, and then they moved on. Next, we have the 408 request timeout. As the name suggests, this is simply just you sent a request to the server, it's taken longer than anticipated, and therefore the web server has just killed the request pretty much and it's just not going to reply. It will just give you the 408 and leave it there. Often I receive this status code when I'm telling the web server to reach out to something. Let's say, for example, I want to make the web server reach out to my local server, but I messed up basically the IP or the host name. The server has then tried to reach out to a non-existent host and then waited, a few seconds or a minute or so for the host to respond. And then after it hasn't responded in a while, the web server's gonna be like, yo, I've got better things to do than process this request. I'm gonna leave it here and issue a 408 request timeout. Then we have the wonderful 418. I'm a teapot. This is simply a bit of a meme. It's just basically the web server saying that I refuse to attempt to brew a coffee with a teapot. And that's it. That's literally in the RFC for the HTTP protocol. And finally, we have the 429, which is literally, as the name suggests, we're sending too many requests. The web server doesn't want to process them all. So to avoid, denial of service attacks and this and that, the server's literally said, yo, chill out. Here's a 429, be done with it. And just not process our requests from there. Finally, let's take a look at the 500 series status codes, which pretty much means that the server has died to some degree, whether that was based on our input or based on the server's processing. Something's happened on their end where it just can't process our request. So first we have the 500 internal server error. This is literally the server has encountered some kind of problem or situation and it doesn't know how to handle it. This could, for example, come in the case of where I'm using like Java, for example, and I sent some kind of data, some kind of input, and the Java has not been able to process it properly, so it's just literally thrown a 500 at us and probably a stack trace and this and that. Really, it's a case of the server just kind of dying. This can actually be used for enumerating like versioning and paths and stuff like that, and also be used as a way of identifying, okay, I submit this input and it didn't break. This input broke it, therefore I need to obviously figure out a balance to get to where I want to be. For example, removing certain special characters that may be breaking something, or a quote or a single quote, etc., and that kind of thing. Next, we have the 501, which, much like the 405 method not allowed, is basically telling us that the way we sent the data isn't supported. For example, we sent a post request when it only accepts gets. Then we have the 502, bad gateway. This is often server-side errors and probably won't have anything at all to do with your request, but basically what it will mean is that the server is having issues giving you a response. For example, it could be using a proxy to go ahead and actually reach back to the backend web server and then give you a response based on that. In this case, it's having issues accessing that. So for example, the upstream proxy that you're connecting to may not actually be working and therefore having issues accessing the proper web server, and therefore it's giving you a bad gateway error. You really only really get this when you're working with, like I say, a web application that's using proxies and other bits and pieces between where it's having issues. This is where you probably use the trace HTTP method to see what's going on under the hood. Making it to the final three, we have the 503, service unavailable. This is a friendly way of saying that basically the web application is down for maintenance or it's overloaded, and when you issue a 503, you often provide a friendly page, for example, saying, we're sorry, we're down, we're sorry, we're having problems, and that kind of thing. Then we have the 504 gateway timeout. Very similar to the request timeout, it's basically the same except it's in regards to the gateway. And if you haven't died of boredom already, because we've been talking about status codes for 15 minutes, finally we have the 506 HTTP version not supported, and simply it's a case of you say using HTTP version 2 when it only supports version 1, as the name would suggest. So that pretty much rounds it up in regards to status codes. Hopefully going through them and talking about examples where I've come across them has been helpful. I think a lot of them you won't have really need to know about, but it's very important to know what they are, what they mean, and really just, be able to peek under the hood by just seeing how the server's reacting to your requests or, subsequent requests. Congratulations. You're now one step closer to being a web hacker. Join me in my next series to learn more, develop, grow, and become the best web hacker. Oh, and like and subscribe. That'd be super helpful. Thanks.
Yeah.